Okay, so here's part two. There are two formulas that are going to help us find the slope of a tangent line using limits, and this is formula two. The concept behind this one is a little bit different, all right? In the first one, we had f of x, and we had f of a. We had x, and we had a. We are not talking about two different x values now, okay? So before we had we had a, and then we had x, and then we had f of a, and then we had f of x. The concept is a little bit different now. We're still using a limit, but instead of using a second x value, notice what we've done here. The 2 points, so this point, this is still a and f of a, okay? That stays the exact same. But instead of using a different x value, what we're going to do is we're going to add a little bit to the a value, and instead of being x2, we're going to express this next x value as a plus h. Now there's benefits in this, and there's some drawbacks. The benefit is this, is that we don't really have to deal with another x value. We keep the a the same, and instead of having this x2 value, we're not going to have to factor a binomial out of any kind of equation. But before I get to that, let's see what this slope formula would look like. Okay, so remember, slope of the tangent is still what we're going after here. It's the slope of this line right here. And the slope is still change in y divided by change in x. So what does that look like now with this new setup? What does it look like? Well, it would look like this. The change in y values is going to be, if this is if this is a plus h, the function value is going to be f of a plus h. And this is the little drawback of this formula, is that f of a plus h is a little bit trickier to expand out and to use. But we're not going to have to factor out a binomial. So just wait for it. So we actually have f of a plus h as our y2, and we're going to subtract f of a. So the f of a stays the same. It's just this part now that changes. You see that? And so again, we're looking at slope. And so what does the slope look like over here? Well, this part here is a plus h minus a. Okay, so that looks okay, but notice we can actually simplify the bottom here. So the slope of a secant line connecting f of a and f of a plus h, the slope is going to simplify to this. F of a plus h minus f of a all over, and what does this simplify to? Well, a minus a. This just simplifies to h. Okay? So that looks quite a bit different than before, right? But it's still an expression for the slope of the secant line connecting a and the x value of a plus h, or f of a and f of a plus h. So it's still a slope function. And if we use our limits, this is what we get. The limit. Now, how do I bring these 2 points together? This is also important. I am going to have to let h, this little bump value, I'm going to have to let the h approach what? I'm not letting x approach a now. What I'm doing is I'm letting h, that is what I'm adding to a, I'm letting h approach what? 0. Okay? So this limit is going to be where h approaches 0. That's very different. So this is a different one. I actually kind of like this one better than the first one. You might disagree, but I like using this better. And you can use either one of these for finding our slope of our tangent, but this is the second one we need to learn how to use. And so we let the limit as h approaches 0. So notice in this diagram, this is h right now. See that? As the points come closer together, let's say the point comes here, then h gets smaller. See that? That's h. And as h approaches 0, that means the little bump from a approaches nothing. And so it's going to look like this. Okay, so the strength of this one is that we still kind of have to monkey around with this a little bit. We're going to have to expand this. This f of a plus h is the tricky part now. Instead of factoring a binomial out, all we have to do is factor an h out. And then we can eliminate the h's, and then we're good to go. And so factoring one h out of the top, as opposed to factoring a binomial out, is a lot of times a little easier. Okay, so that's the basis for Formula 2. Okay, and as I just mentioned here, Formula 2 is often considered easier because it involves expanding on the top multiplication. Notice the f of a plus h, right? This is expanding and multiplying and then gathering like terms. And it also involves only factoring an h out. And so that can be a little bit easier. Okay, so I don't know if I want to start with this example, actually. I was going to change my mind here. Let's do something a little bit simpler, okay? What do you guys think? Should we start with something a little bit simpler? I don't know. I think we should start with something a little simpler. So let's say, let's use standard y equals, well, let's do x squared, okay? Y equals x squared. So that's a parabola. Everybody knows that. It looks like this. And let's find the slope, okay, using our new Formula 2, okay? Find slope, Formula 2, at x equals 2. X equals 2. Easy peasy, right? I mean, easy. So let's see how this Formula 2 works. Let's take it for a ride, okay? Let's take it for a little ride here. So I'm going to write my formula here where I can see it, and that formula, let's write it up here. So the limit h approaches 0 of f of a plus h minus f of a all over h. That's my formula. And again, the tricky part, the whole tricky part of this is going to be this right here, okay? Just to let you know. Because once we get more complicated functions here, you have to put in a plus h in for every x. So where do we go from here? Well, we know a is 2, right? This is the point of tangency, so a is 2. So I'm going to rewrite this limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Okay, that's your first step. First step. From pre-cal 30, we know that if you have f of something, whatever this something is, it goes in for the x, doesn't it? It goes in for the x in your original equation. So this starts to look like this. F of 2 plus h is actually 2 plus h squared. So remember composition of functions? Okay? 2 plus h goes in for x. And so it's actually 2 plus h all squared. Right on. So what's f of 2? Well, if you put 2 in for x, that's 2 squared, that's 4. All over. Now h doesn't change. We're going to leave h as it is. Okay? So now that you've overcome that hurdle, like I said, the trickiest part is this right here. If you can manage this and transform that into this, that's the trickiest part. And then you have to expand and simplify, gather like terms and all that sort of stuff. But that's the trickiest part. If you can get past that, then factoring an h out is going to be easy. Because as you'll see, all of your constant terms should cancel out. And all you're left with is h terms, so you can factor an h out of that top pretty easily. So let's continue on. Let me show you. So the limit as h approaches 0. That's a binomial squared, so I'm going to do 4 plus 4h plus h squared, right? Minus 4 all over h. Gathering like terms, I see that I have a 4 and a minus 4. I can gather those, and that conveniently comes out to 0. So I have the limit as h approaches 0. This is 4h plus h squared over h. Now I want to be careful and take my time here, but you can kind of see that, hey, I've got an h in each of these terms in the numerator, so I'm going to be able to factor that out. The limit as, I don't know where x came from there, as h approaches 0 of, and I'm going to take that h out right here, and I'm going to leave 4 plus h there over h. Now, you see this? Beauty. Beauty. H over h, gone. So now this limit totally simplifies, right, to this, 4 plus h. Now, if I put in 0 in for h here, look what happens. I have 4 plus 0, and the limit is 4, which turns out to be, oh, what did we set? What am I finding the limit of? Oh, yeah, this, which is the slope of the tangent line under this new system, okay? So this becomes the slope. Now, some students prefer Formula 1, some students prefer Formula 2. I think it will depend on a few things, which one you prefer, but let's do some more examples so we can get a little more accustomed to this. So here's that example 3 that I had set up for us at the beginning. Let's tackle this one here now. And I think in the previous lesson, I think we did this one with Formula 1, right? So, all right. So again, I'm going to rewrite my Formula 2, f of a plus h minus f of a all over h. And I know that my a is 6 here. And my f of a is, according to this, it's 2, right? So this is the x value, here's the y value. Awesome. So here's my equation. So again, the toughest part is the first part there. So let's make sure we get that right. A plus h is actually, and I'm going to change that now, a is 2. So I'm going to put, no, it's 6. So it's 6 plus h and f of 6, right? A is 6 and f of 6 is 2. So the first part here, tricky part, I'm going to put 6 plus h inside my function in place of x. So this looks like this. Are you ready for it? 6 plus h goes in for x. And then I actually have to do a minus 2 there. All right, so what I just did was I did f of 6, because 6 is a, f of 6 plus h, and I put 6 plus h in there for the x. And so f of 6 plus h is actually root 6 plus h minus 2. Okay? Trickiest part, if you can get past that part, you're as good as gold here. Minus f of 6, which we said was just a plain old 2, over h. Okay? So that's the kind of the first 2 big steps there. All right? Let me know if you have any serious questions about that. If you're in my class here right now, let me know. I am going to highlight the fact that in order to liberate, or in order to get an h out of the square root, we're going to have to rationalize. So we've been doing that, doing some practicing with rationalizing numerators and denominators. So I could do some simplification here, then I'm going to have to rationalize my numerator. So here are the next 2 steps for you. Root, this is 6 minus 2, so that's 4 plus h, or h plus 4, doesn't matter. Minus 2 out there, over h. So as mentioned, I'm going to have to rationalize this numerator. So I'm going to multiply by 4 plus h plus 2. And what I do to the top, I have to do to the bottom. Okay. Now again, this is how we're going to get rid of the radical, because I need to get this h out of there. I can't just pull it out as a factor, right? It's underneath the root sign. So this is actually root h. I can't just factor an h out of there. I have to be careful with this. And plus it's bound in this sort of polynomial there. So if I do this, as we've seen before, we're going to be able to get rid of the radical up top. So I'm going to do that. When I multiply these 2 binomials now, this times itself really is just 4 plus h. FOIL method will give me a plus 2 root 4h minus 2 root 4h. See that? So those 2 terms eliminate. That's why we get a difference of squares when we multiply this. So it's going to be minus 4 over h. Now you should be pretty excited here, because this is super simple now. I have 4. Look at this. I have 4 minus 4. And what am I left with there? Just an h. So limit as h approaches 0 of, this simplifies to h over h. What? With this on the bottom. I forgot to write this out a second time. So 4 plus h, we still have that on the bottom. Sorry if I alarmed you. I alarmed myself. Okay, so root 4 plus h plus 2. All right. So when you eliminate the h's now, so it's going to be easy. All right, so we've got h over h. That's gone. And of course, this simplifies now to the limit as h approaches 0 of 1 over root 4 plus 0. Sorry, 4 plus, let's just put an h there. 4 plus h plus 2 on the bottom. See that? Okay. So I've rationalized the top. I've got rid of the radical on the top. I still have a radical on the bottom, but as you check, if you put in 0 here now, notice that I'm not going to have a problem with dividing by 0. Okay. So I've just manipulated, I've just rearranged this rational to show a different form, and I'm going to be able to use substitution now to figure out this limit of the original equation. So what this means is I'm going to go 1 over root 4 plus 0 plus 2, which is 1 over root 4 plus 2, which is 1 over 2 plus 2, or 1 over 4. All right, so give me a second to check my work. Okay, so I checked things over and, of course, looked back to our notes from last lesson here, and here it is. This is using Formula 1. You get the same slope, 1/4. So we should be able to use both Formula 1 and Formula 2 here, and we should be able to get the same slope. So it works either way. Slightly different concept, but should yield you the same answer. All right. Let's take a look at this question. This is example 2. And here what we're going to do is we're going to sort of introduce some application for this. Okay. Remember, when we find the slope of a tangent line, that is an instantaneous rate of change. Okay. It's an instantaneous rate of change. So as mentioned before in previous lessons, if we had the displacement in meters, okay, so meters of a particle moving in a straight line, where t is time measured in seconds, notice this, the rate of change, whether it's instantaneous or average, is going to be rise over run, m over s, or meters per second. So that's going to be your velocity, okay? So if we have something like, something like this, and we have a secant line, that's average velocity. And if we had, of course, a tangent line somewhere that touches at one point, that's instantaneous velocity. So let's not lose sight of what we can apply this to. And a slope of a tangent to a graph is an instantaneous rate of change. So this particular question says, the displacement in meters of a particle moving in a straight line is given by this function, s equals t squared plus 2t, where t is measured in seconds. Find the velocity of the particle after 3 seconds. So velocity, we know, is meters per second. And when the question says after 3 seconds, what it really means is at exactly 3 seconds. So when it hits the 3-second mark, boom, at that instant in time, what is its velocity? So we are looking at a graph, and at t equals 3, we're looking for instantaneous rate of change. That is the slope of the tangent line. Okay? So this is not the graph. I'm just sort of like messing around here. So let's make some space. So we need to find the slope of the tangent line. I know how to do that. We can use either Formula 1 or Formula 2. Since this is Formula 2 lesson, let's use Formula 2. The limit, as h approaches 0 of what? F of a plus h minus what? F of a, all over what? H. Okay. Don't put x minus a down here. Don't mix them up. And you should notice that because there is no x in the top. No x in the top. So if you mess this up, and if you get these messed up for some reason and you do this, I've seen it happen before, notice that you say, wait a minute, I've got no x in the top. How can I have an x minus a in the bottom? You can't. Okay, that's how you know you've got something wrong. And don't worry, you're going to make mistakes. You're going to mess up. Okay, you're going to miss a sign, right? I've done that too, right? So you're going to miss a sign, and you're going to have to go back, and you have to double check. You're going to have to make sure your math pans out, but get the formulas correct here, and you're good to go. So let's do this thing. H approaches 0. So what is A? Well, A is this 3, right? A equals 3. That's the moment in time that we are concerned with. We want the instantaneous rate of change at 3 seconds. That is, we want the slope of the tangent line at x equals 3, or t equals 3, which makes 3 the A value here, okay? So this is going to be 3 plus h and f of 3. And I'm just going to show that here now. So that's going to be 3 plus h and f of 3. You guys good with that? So what's that going to do? Well, I have to put 3 plus h in for t. Wherever I see t, I have to replace that with 3 plus h. Remember, we're taking the time and we're just bumping it h units. So that means that everywhere where we have a t, I have to replace it with the t value plus h. 3 plus h. Everywhere where we see a t in the original equation. So I'm going to do this right now. 3 plus h what? Squared. That's from here. Plus 2 times what? Oh, 3 plus h. Remember, that's the trickiest part of this whole deal. If you can get that, if you can see that this right here, f of 3 plus h, is this right here. If you see that, if you understand that, that's half the question right there. That's half the difficulty right there. Okay? All right. I'm going to move back here. So f of 3, well, f of 3, I guess I'll just write that out. It's going to be 3 squared plus 2 times 3. Okay? Look good? All over what? H. I don't have to do anything with that denominator. It's pretty simple. Okay, so let's take a look at this again. 3 plus h, I put 3 plus h in for my variable. Good. I put 3 in for my variable on the second part. Excellent. Okay. So what is f of a? Should be 9 plus 6 is 15. So f of a is that right? 15? 9, 6, 15? Okay. All right, so what we have to do now is we have to expand, and we have to gather like terms, and we have to simplify that numerator. It's going to be a jumbled mess, but we have to expand now. So let's do that. All right, so limit as h approach. Yes, you have to write this every step. Yes. We're finding the limit. Okay. 3 plus h squared. Well, that's going to be 9 plus 6h plus h squared. FOIL method, right? Should be able to do that in your head by now. If not, go ahead and write it out on the side. Do it quick. I don't care. But that's what this becomes. This becomes plus 6 plus 2h. You see that? You can distribute that in. Plus 6 plus 2h. Okay? And then minus, we said this was 15. Okay? You good with that? See what I'm doing? All right. So let's start gathering some like terms. Well, I have 9 plus 6 minus 15. Those are all constants. And that, wonderfully enough, gives me 0, doesn't it? Boom, gone. Which is really amazing. Now this should happen every time, actually. It should happen every time. You shouldn't have any constants left over once you've expanded and gathered like terms. You should only have terms with h in it. Beauty. That's super good. Gonna make this super easy. What other like terms do I have? Well, it looks like I have an h term here and an h term there. That's also awesome. So 6 plus 2 is 8. So I have 8h, and this is a lone partner there. There's nobody else there. So 8h plus h squared all over h. See that? And so then I factor, yes, I have to write this out again. I factor an h out, 8 plus h over h. Okay, moving over here. Those h's are gone, and this simplifies to 8 plus h. All right. When I substitute in 0 for h, I don't have any problems. I'm not dividing by 0. I'm not taking the root of a negative or anything like that. So this is 8 plus 0, and that means that the limit is 8. So what this is saying is that at exactly 3 seconds, the velocity of the particle that obeys this function, the motion path made by this function, should have an instantaneous rate of change of 8 meters per second. So what's the velocity? It's 8 meters per second at 3 seconds. Boom. And that is your final answer there. Okay? Let me know if you have any thoughts or questions or concerns about that. So now I want you to take this example that we did last lesson with Formula 1, and I want you to use Formula 2 to find the slope of the tangent for this one right here. Okay? So go ahead and take a few moments and do this with Formula 2, the one we just learned today. All right? So pause the video, just take some time here now to give this a try, and I'll show you the answer in a minute. Okay, so hopefully you've had a chance to take a look at this. If you're still working on it, you go ahead. I'm just going to do it here on the screen. So we're going to find the limit as h approaches 0, and again, that's going to be f of a plus h, a plus h minus f of a all over h. And of course, a equals 2 here. Whatever the x value is, the point of tangency there, that's going to be the a value. And this, consequently, if they give you both coordinates at the point, perfect, less work for you. That's f of a, okay? So that's f of 2. This is 2, so a is 2. You're good to go. So here we go. H approaches 0. My limits are getting really messy now. They're not great. So f of a plus h. Well, a is actually 2, so I'm going to have to do 2 plus h. Again, trickiest part right here. 2 plus h minus 2 plus h squared. Boom. If you can get that, you're more than halfway there. One more time. F of 2 plus h, because a is 2, equals this. You see that? So I'm putting 2 plus h in for the x's here. You got that? Golden. So what do we do now? Well, now I have to expand, do a little multiplying, do a little gathering like terms, and then we'll see where we are at for there after that. So what is this? 2 times 2 plus h is going to be 4 plus 2h. This is going to be minus. Now, please be careful. You're subtracting multiple terms now. So use your brackets. This is going to be 4 plus 4h plus h squared. Okay? Do your FOIL method. Okay? So we're subtracting all of these terms now. So please don't get that messed up. 4 plus 2h. This is actually going to be minus 4 when we distribute here. Minus 4h minus h squared. So hopefully you got that. All right, moving up here. Limit as h approaches 0. So can I gather like terms here? Let's see. Well, I've got 4 minus 4. Oh, beautiful. Haven't messed up because we've gotten rid of all the constants. That's awesome. And I've got a 2h minus 4h. So that's going to be a minus 2h. Okay. So negative 2h minus h squared all over h. Okay, you guys with me there so far? Got all our signs in order there. And of course we had this minus 0, right? That was, I just dropped that. So if I take an h out, I can actually, could I take a negative h out? You don't need a negative h out because you just got a positive h here. So let's take an h out. That's negative 2 minus h all over h. H is a funny word, don't you think? H. H. Sometimes when I say h so much here in teaching calculus, it's like, that is a crazy, weird word. H. I don't know if anybody else noticed that. Okay, so h divided by h is gone. And I should have now just negative 2 minus, I'm going to substitute here now. So I should have, I don't know, negative 2. Does that sound right? Okay, let's check my work here. All right, so it looks like everything is working out right. Now, just for comparison, this is the same question using Formula 1, okay? And we did that one here, and notice that we factored out and divided out the factors. Of course, with this Formula 2, we don't factor and divide out factors. We expand, gather like terms, and then divide out the h's, okay? So it's slightly different, but now you've learned how to do Formula 1 and Formula 2, and you should be able to do all of the same questions with each formula now, okay? And that's all I have for you for today. So that's part 2, Formula 2, finding the slope of tangent lines using limit Formula 2. Yeah.